Thank you very much for the switch over there, Luke, and welcome everybody to this panel series. This is a joint initiative between the two academies, the Australian Academy of Technology and Engineering, ETSI. This is hosting the session today, as well as the Academy of Science. Both of these academies have got respective committees and forums which are working on the common goal relating to Australia's digital future. All right, so as the attendees come in, can I start by acknowledging the traditional owners of all the lands on which we work, live, and learn, and pay my respects to the elders past, present, and emerging who continue cultural and spiritual connections to country. So my name is Shazia Sadek. I'm a professor of computer science at the University of Queensland based in Brisbane. I'm wearing a couple of hats today. I'm the chair of the National Committee of Information and Communication Science at the Academy of Science, and also part of the executive of the Digital Futures Forum here at ETSI. So this expert panel series is one of the activities that we have been undertaking as an outcome of a strategic plan that we jointly published back in 2019. So the strategic plan for Australia's digital future was published in 2019. After that, we followed up with some implementation activities. And this particular panel is focusing on one specific recommendation from that plan, exploring new and better ways to enable research industry collaborations. I might put a couple of links into the chat at a later time, which will refer you to the strategic plan, as well as the work that's going on in ETSI with respect to the digital futures. Now, the first of this panel was held in June on next generation satellite communication systems. That was chaired by Dr. Sarah Canet from Smart CRC. It had four esteemed speakers: Dr. Jared Balding from the DST group, Dr. Doris Grosse from ANU, Peter Kerr from Smart SAT CRC, and Professor Craig Smith from Electro-Optic Systems. In this panel, we are going to talk about a much talked about digital technology, that is artificial intelligence. So we outlined this in the panel brief. Just to reiterate, you know, we all know that the reality is AI is already all around us. AI-powered technologies are being developed and deployed at an unprecedented rate. We also recognize that this progress rather is asymmetrical. The growth for consumer internet companies has been extraordinary, but many other sectors which are highly relevant within the Australian economy, such as manufacturing, finance, agriculture, have yet to fully harness that potential. So how can we overcome this gap between a successful AI proof of concept and the challenges in putting those systems into production? So there are some fundamental scientific and societal challenges that we need to overcome to make AI more accessible. And we certainly see that a strong and meaningful research industry collaboration is a key ingredient of this solution, and hence this panel. So we are really delighted to have Professor Sveta Venkatesh, who will present the research perspective. We have got Nick Terkelson-Terry, who brings the industry perspective. And we also have Professor George Simmons, who will talk about challenges and opportunities relating to the application of AI, and specifically in the field of education. So before I introduce our speakers, some quick points about the session. So basically, I will invite each of our speakers to present an opening statement to start with. We will then open the floor for Q&A. You are welcome to type out your questions in the Q&A function of Zoom whenever you like. It will be great if you could address your question to the specific feature of speaker, unless it is for everybody. And lastly, just a note that this session is being recorded. So without any further delay, it is my pleasure to introduce our first panel speaker, and that would be Sveta. I'm going to read out Sveta's bio to make an introduction. So Professor Venkatash is an ARC Australian Laureate Fellow, an Alfred Deakin Professor, and a co-director of Applied AI Institute at Deakin. She's also an elected fellow of the International Association of Patent Recognition back in 2004, fellow of the Australian Academy of Technological Sciences and Engineering from 2006, and a fellow of the Australian Academy of Science in 21. And in 2017, Sveta was appointed the Australian Laureate Fellow. As we all know, this is the highest individual award that the ARC can bestow. Now, Sveta and her team have tackled a wide range of problems of societal significance, including critical areas of autism, security, aged care, and those outcomes have impacted the community and involved into publications, patents, spin-off companies, almost 700 publications, 3 full patents, 1 startup company called Isotana, 2 significant products, Tobii PlayPad and Virtual Observer. Sveta has been tackling complex pattern recognition tasks by drawing inspiration and models from widely diverse disciplines and integrating them into rigorous computational models. And her main contributions, as I know, have been in the development of the theoretical underpinnings and frameworks, as well as the novel applications. So with that, over to you, Sveta.
Thank you, Shazia. Hello, everyone, and it's great to be on this panel. And I thought I'd use a few slides because it's just easier to convey some of these concepts. So if you don't mind, I'll just share my screen. Sorry. So what I want to talk about today is what I call sample efficient AI, and I'll explain as to why I think this is a significant area of AI. So the other way of thinking about sample efficient AI is to think about it as an efficient way of navigating complexity, and it really provides the underpinning of how you can use machine learning to disrupt the process by which we innovate. But so before I start, I want to talk about this person called Ibn al-Haytham, who in 965 wrote this absolutely beautiful book on optics, whose cover you see there today. But he was also the father of the scientific method. And he was the first person who said that a hypothesis must be proved by experiments based on confirmable procedures. And this kind of, this underpins our scientific method and the design of almost anything we do, design of products, other than if it's, like pure science, like mathematics. Like most experimental fields will have experimental design as their underpinning. So this kind of experimentation drives the scientific inquiry, right? So you perform an experiment, you measure the result, and you change the control variables. And you do this again and again and again till you reach the target. So you would say, what's so difficult about this? Well, it's difficult because as the number of these control variables grow, it becomes hard to know what you're supposed to change, because it's almost impossible to change all possible combinations of the variables that you have. And to give you a sense of how difficult it is, I'm just going to consider a hypothetical problem where you're testing a car and you only have 10 variables. And let's say each experiment takes you 100 hours. This will take you 12 years to finish combinatorically. So it's almost impossible to do the simplest of experiments. So of course, you could say to me that can't be true because we drive cars pretty safely. So what do? But what we do is we simplify, and we actually don't know how far from optimal we are, right? So it's over-engineered solution. So the question is, can you do the minimum number of experiments, and we can accelerate this kind of experimental design, and can AI help us to do this? So this again conveys the same kind of idea. If you have a bunch of variables, like these are your control variables, what you can change, and the number of experiments that are required. If you have just 3 or 4, you can just use Excel. If you have 6 or 7, there's a classical method called design of experiments, which you can use. But you can see that if you get to even 8 or 9, which doesn't sound like much, it's impossible. So what we propose through machine learning is this thing called adaptive experimental design, where you see that as the number of variables increase, it gracefully increases with respect to the number of experiments required. So why is this useful? This is useful because it allows you to navigate these kind of complex systems efficiently. And this gives you a huge competitive advantage because you have to do fewer experiments. So there's lower developmental cost, faster entry to market. And that's why the space is open to us as researchers. Now, I'm going to talk about some of the problems that sample efficient AI can help you solve. Like, of course, it can help you solve problems where you increase the number of variables. And even your classical design of experiments have no method of transferring knowledge from one experiment to the other. And if you have completely unknown search spaces, so if you're inventing a totally new alloy, for example, how do you do it? And some other aspects of this that it will impact as I go along, I'll talk a little bit about that. But first I want to say something, which is translation and fundamental science kind of go together. And I'm sorry that this thing is on the top, but I'll try and put it at the bottom. And essentially we've used this kind of method to work with experimentalists to invent new nanofibers, invent novel biomaterials, invent new types of alloys. And I want to make the pitch that it's translation and science, development of science go together. It's not an afterthought. You don't develop your algorithm, go looking for the solution, but in engaging with this and making all these absolutely novel products and materials, we learned to do a whole bunch of new machine learning problems that I want to talk about as well. So I want to, So the first, I'll give you a couple of examples of what we did with experimentalists. The first one is the design of novel short polymer fibers. Now, these polymer fibers are really interesting because they can be sprayed or painted onto anything, and they have endow them with a lot of properties. And they wanted to make these fibers which have a certain target length and target width. And we helped them do this by reducing the number of experiments from something like 100 to about 10. So you get orders of magnitude improvement in the number of experiments that have been done. This is one that we are very we call it the just chuck it in alloy. And the idea here is, how do you build an alloy with the largest composition so that it will have a strength within a certain band? And if any of you work with alloys, you'll know that alloys currently have a very, very narrow band. And they stay in this narrow band of composition because if you go outside it, it goes all crazy, right? So we came up with this alloy. And again, the search space for this is absolutely huge. It's something like 10 to the power of 8 possible combinations. So the idea here is, can you create this alloy with this flexible composition that can accept a varying and unsorted metal waste stream? And that's essentially the problem that we solved in this, and we were able to come up with a solution for this. It's not just in invention of these kind of materials that you use this kind of technology. You also use it for strategy selection for public health. So in this one, we were working with the WHO Obesity Institute in Deakin to try and see whether they could come up with a method by which they could formulate new, understand how GPs would prescribe more exercise scripts. They wanted them to do that. And there were like 8 strategies to do that. And normally it would have taken 2 years to complete. And essentially we, with our method, were able to determine it in 7 weeks. So that's very, very useful. And the last part I want to talk about in these few minutes is, how did this translation really help us innovate in machine learning, right? And what it helped us do is advance new machine learning models. So it helped us do a whole bunch of stuff, but I'm going to take, like transfer learning and high dimensional Bayesian optimization. But I'm going to take like 2 concrete examples to show you what kind of things it does. So the first one is what I call algorithmic assurance, which comes under responsible AI. So the thing is, how, for example, do I find the maximum difference between the algorithm and a gold standard? And we can use the same kind of approach that we're talking about to do it. Similarly here, we want to be able to search so that the cost of one element, which is expensive, is used less. So the one that's not cost effective is using, let's say this side is, the x-axis here is gold, it's using a lot of gold, but the green one uses much less gold to get to the correct solution. So these are new machine learning algorithms that are cost aware, that we understood we had to do by working with experimentalists. And and this is an example of assurance. So if, for example, you want to know when an algorithm will fail, let's say it's an object recognition system and there's shadow size and shadow number, the color here indicates how well this color indicates how well that algorithm is going to work. So in these areas it works, and in the blue areas it fails, right? So it allows you to get an understanding of where precisely your algorithm will fail by using these kind of sample efficient methods. So essentially, I just wanted to make this kind of shall I stop sharing screen? No, sorry. Yeah. I just wanted to say that sample efficient AI is a very different kind of AI from the deep learning type of AI, but it has huge impact in experimental design and in accelerating innovation. So maybe I stop there, Shazia, and can move to the next speaker.
Thank you so much, Sveta. I mean, I'm going to hold on to that comment about translation is not an afterthought, and we'll come back to it later. So some great examples from polymer fibers, digital health, alloys, and so on. So yes, let us move on to the next speaker now, and it is my pleasure to introduce Nick. So Nick is a CEO and co-founder of Max Kelsen. It's an Australian AI company working with enterprise customers around the world, some big ones like Johnson & Johnson, Woodside Energy, Domino's Pizza, and many others. Max Kelsen is involved in the full AI life cycle, from fundamental research through to building new AI-powered products, and has a focus on healthcare and life sciences industry. And they've developed multiple regulated products, translated into clinical settings. Nick is also the founder and chairperson of Queensland AI Hub, and can I also personally say that a great champion of research industry partnerships. So over to you, Nick.
Thank you so much, Shazia, and good to be here. I think just to kick us off, when I read the topic for today, I thought that sounds like a conversation I have 100 times a week, which is really this question of, you know, there's a dichotomy in the AI world. There's a digital natives which have screamed ahead with leveraging AI technologies to create billions of dollars worth of competitive advantage. And really what we'd think of as the real economy, which probably hasn't seen the same type of impact that they probably would have expected to see based on the investments that have been made across the economy. And so I get asked very regularly by our clients as to, you know, what are we doing wrong? Why is this the case? I think it's worth us just thinking briefly about some of those competitive advantages that have been made by our digital native peers. And probably the example I like to use the most is the example of Spotify. Now, Spotify, most of you will use, most of the world uses. It is still the preeminent music streaming platform, but I would posit that actually it doesn't deserve to exist because it has no moat, it has no competitive advantage over its peers, insofar as Apple or Amazon, you know, et cetera, have the same catalog, yet have economies of scale, which should mean that Spotify essentially either needs to get bought or it ceases to exist. For example, if you have a Prime membership on Amazon, you get basically the same catalog for $7 a month. You also get music, TV streaming. You also get next day delivery for free, et cetera, et cetera, et cetera. The value proposition is far, far stronger. So why do customers continue to pay extra to access Spotify? I think that it comes down to recommendations. I think it comes down to how personalized the service is and how those teams have leveraged AI to create a truly differentiated product with a commodity service or a commodity set of products sitting under it, which is an interesting point to think about in traditional businesses when we're competing, which is how can we use AI really cleverly to create totally differentiated customer experiences which create value for our customers on top of the commodity that we might be selling under it, whether that's a manufactured good, whether that's a service or experience, whether that's a hotel, whether that's a pizza. It could really be anything. And so the question therefore comes as to why have these companies been so successful at leveraging and deploying AI technologies, and really those in the real economy, and particularly those in Australia and New Zealand, have not, and really we would think of as laggards. And so I wanted to share a couple of points today of what I've experienced working with these customers and where I think some of the pain points are. I'd say that the first thing is a misunderstanding or a misdiagnosis of actually what AI technology is and the people that go about building it. And that's to say that it takes a village to build a machine learning or AI product, not just a data scientist. And so what we see in traditional enterprise is an industry that's growing out of the analytical sciences, growing out of, looking at in the rearview mirror for insights with data, and essentially is looking to use those same sort of team structures and same sort of people to approach what is a completely different problem, which is, live in production, productized experiences. And really what we see is a massive skills gap on the engineering front. So whilst we might have very smart data scientists that understand the statistics and understand the business problems, we see a big gap with translating those to production due to the lack of fundamental engineering capabilities, due to the lack of experience in platform engineering and DevOps teams with machine learning problems and so on and so forth, even through to a lack of understanding of product managers and UX designers as to how to think about the productization of these experiences and how to design around them. We find these skills very, very prominent in Silicon Valley, in Tel Aviv, and in other startup hubs around the world, and is generally well held onto by the digital native folk that I spoke about earlier. There is a lot of depth of experience out there, but it just hasn't yet arrived on our shores. And so we do see a real skills gap between what the industry needs, or what industry needs to be able to build and leverage these technologies to what is actually available in market. That's probably the first point. The second point is to understand the landscape of regulation and risk as we move out of unregulated digital products like music streaming or social media or shipping low-cost goods. We land in an area of a completely different risk environment. So as Charles mentioned, at Max Kelsen, we do considerable amount of work in the regulated healthcare space. We build diagnostics and digital therapeutics, which are regulated by the regulators like the FDA and the TGA, et cetera. As at today, we see a very, very naive and immature landscape of regulation around these products in the healthcare sector. And what I can safely say is that the healthcare sector is a long way ahead of the rest of the market in terms of their maturity in assessing these. Moreover, we see a great difference between how the FDA is thinking about these products versus how the TGA is thinking about these products. And so establishing mature regulatory frameworks which give executives and businesses the confidence and understanding they need to build and deploy these products into high risk environments is critical. We see this particularly in financial services, both here in Australia and around APAC, that there is not a good understanding of how machine learning should be used in the credit decisioning process, for example, how it should be governed, how equitable measures should be incorporated into the design principles of the system. These are all fairly well understood academic principles. And if, on the topic of partnership, if you were to work with really any great academic partner here in Australia or probably around the world, you would get really great answers to these, but they haven't yet been codified in the regulations. And the regulators are spending a lot of time either resisting the technology or not spending enough time properly understanding how the technology works to understand how best to regulate it. Of course, internally in companies as well, there's a question of risk. A silly example that we use is that we have a system, it's been live for about 4 years. It's used at Domino's and it makes pizzas before customers pay for them. So basically what we do is we watch the online ordering behavior of a customer. When we're certain that that customer has finished their order and that customer is going to check out, we actually send that order straight through to the make line about 4 minutes and 12 seconds before the customer ends up paying for it on average. This, of course, gives Domino's a better delivery experience, a differentiated customer experience, particularly over the aggregators like Uber Eats or DoorDash, who don't control the kitchen processes. That sounds like a relatively low risk activity until you realize that Domino's is making about 1 million pizzas a day without customers paying for them. So it's putting a considerable amount of trust in a machine learning system that it doesn't really understand. And so you ask the question of, well, how does the executive get to do that? Well, in Domino's case, they just did it. But that isn't how most businesses work. And so mature understanding of how to manage risk in these systems, how to assess the risk in these systems, how to build quality engineered systems that are auditable and traceable and resilient is a question that has been tackled by the academic community for many years now. But there are really certain answers to how to do this, and it really takes companies, working with their academic partners to build the maturity in their risk frameworks to be able to bring these technologies on and put them in the real economy. The technologies are there, the maturity around managing the risk is there, and really, resisting doing it is holding your business back. For example, Domino's have been doing that for 4 or 5 years, and they have far newer and cooler technology than that already going out the door. So if you are, if you aren't able to get these processes through, or these programs of work through due to that lack of risk maturity, then it's something that the business really needs to think about, because they're going to find themselves disadvantaged in market to their competition who can and who have done the work. So I think risk is a really interesting point, both from the regulators and from the internal companies. So problem one, we don't have the skills, and that's not just data science skills. I think the skills gap is very, very easily misunderstood with that it's just data scientists that we're missing. It's really not. It's that full ambit of skills I talked about. Secondly, is appropriate regulatory and mature regulatory environments in the real economy industries outside the digital natives. Thirdly, it's internal appetite for risk and maturity around risk management of taking on these systems, because they are probabilistic, etc. And so the question then comes: how do we solve some of these? How do we plug some of these gaps? And of course, I'm here with Charles here, and at Max Kelsen, we're a digital native, born in the cloud AI company. We have 70+ people here that work on production AI systems day in, day out. And yet we extensively leverage a network of higher education partnerships, both in a training sense, where we put, I think we've got 6 students now going through PhDs in different schools around the country, through to joint research programs, are actually around risk and around governance and around regulatory issues in AI to try and push the general field forwards. But it's, I think it's incumbent of everyone to have a look at their bench skill sets and understand where they don't, where there are gaps, and to look to how they can fill those gaps by creating meaningful research partnerships with the academic community, who are, as I said, really versed with the sort of problems that we're having. I think just to close out here, and I'm really interested in the discussion after to talk about how we solve some of these problems, is just to talk a little bit about that translation process. I think in Australia, the translation is obviously an increasing topic for academics and for the higher education sector, as it is for the technology sector. We're obviously here to translate technology. It's important to understand, though, what technology is already translated versus already that isn't. And so that's an assessment of, I think when we think about software, we now think about software as 95% engineering and 5% research. And machine learning, say, or deep learning AI, probably 5 years ago, we thought about 90% research and 10% engineering. I think it's worth us thinking about where that dial currently sits. We're probably, 60% engineering, 40% research these days. And so, the question needs to be asked as to what is the appropriate things for research to be focused on, and where is the technology sufficiently mature that it can just be implemented, for lack of a better word. And I think that also comes down to the division of responsibilities between, even internally in different companies, between research, data science, machine learning engineering, and then in platform and production and SRE teams, and how these programs move through a full life cycle of starting with a business case and moving through to fundamental research and moving through to experimentation, and then moving through to engineering and deployment and post-market surveillance and so on. So they're just some ideas that I wanted to put out there. Like I said, this is a conversation I have really, really regularly, and it's definitely not something that I think anyone in the market's doing well. So those that think they are can probably take a look in the mirror. And really, we've got a long way to go to catch up to our peers in in Silicon Valley and Tel Aviv and other places around the world that are rocketing ahead and creating truly global competitive advantage using these sort of technologies really effectively. So yeah, that's me. Thanks, Shalcia.
Wow, thank you so much, Nick. So lots of food for thought, really. I'm thinking about the the whole trust, customer stickiness example that you gave, with Spotify and then with Domino's. I think the skills piece is really important, and hopefully we can come back to it. I know here at the Academy, Etsy is about to launch a report on education next month, and there's been lots of talk about digital skills. And around the regulation piece, also a very important conversation to have. And thank you so much for that. So now I would like to invite our third speaker for today, Professor George Simmons. So George's research is actually on the intersection of human and artificial cognition in knowledge processes. So professor and director of the Center for Change and Complexity in Learning, that we fondly call C3L, at the University of South Australia. He is also a professor of practice in psychology at University of Texas, Arlington, and has delivered a prolific speaker, keynote addresses in over 40 countries, which have had a profound influence on technology, media on education, various organizations, and society in general. And his work has been profiled in national, international newspapers, including, New York Times and so on. So George has received numerous awards, including honorary doctorates, and he is also holding an honorary professorship at the University of Edinburgh. He's president of the Society of Learning Analytics Research, solarresearch.org, and has advised government agencies in Australia, European Union, Canada, United States, numerous international universities on digital learning and utilizing learning analytics for assessing and evaluating productivity gains in the education sector and learner results. And for those of you who may not know this, George is also attributed to be the inventor of MOOCs, massively online open courses, back in 2008. And current focus or current projects, one is the Global Research Alliance for AI in Learning and Education. This is called Grail.ai. And another one is SenseAI, which is focusing on analyzing how AI is deployed in learning and knowledge settings, and especially the leadership capabilities needed to enable and support this work. So two very important big initiatives being led by George. And over to you, George, now.
Thanks, Shazia, and thanks for the opportunity to spend a little bit of time with the group here. And it was great to follow Sveta's and Nick's overview, because I think both of those are sort of critical areas of interest as well. Especially within psychology, there's long been a grappling with the issues of replication and running these large-scale studies. And when you have studies that have an enormous number of variables at play, such as those that involve humans in human conditions doing human things, different models and methods for conducting and running those experiments, and how you begin to isolate and understand which factors actually are consequential start to become really critical. And now I know what Sveta was talking about was in a more confined space than the human behavior space, but by the same account, with something in the range of 70% of AI models now being developed with synthetic data, when we start to talk about things like learner profiles and learner states and computed curriculum, I think it's quite reasonable to expect that in the domain of human performance, alternative experimental techniques will start to become critical areas of interest going forward for researchers, whether educators or psychologists or computer scientists. The points that Nick raised, I think, are quite critical and dear to heart as well. We recently received an award from the South Australian government to develop a data science hub, and for that same reason, which is the data skills are critically needed, and a colleague, Srečko Joksimovic, is leading that particular initiative. And there's a need for us to find alternative ways to reskill. And some of you may recall a Kaggle survey from a few years ago detailed that about 60% of the people entering data science fields actually did not receive their training through a formal university program. Instead, they learned them through massive open online courses, or they learned them on their own or in their own areas of interest. So now we're faced with an enormous challenge, I think. Just nicely framed by the previous speakers. One is that understanding and making sense of the human condition as it relates to learning and knowledge processes is a critical need that we face societally. Secondly, we don't really have the knowledge infrastructures to build those human skill sets at scale. We have obviously brilliant one-off labs and brilliant individuals in those settings that are solving complex, intractable problems in social spaces. But we aren't doing it at scale, and we are laggards, as Nick articulated as well, compared to many other regions and many areas of the world. So I want to talk a little bit about what I see is both the challenge and the opportunity. During COVID, there were at various times in the range of 13 to 1,500 academic articles being published around COVID and COVID research. Now, clearly, it's nearly impossible for an individual educator or researchers to stay on top of those kinds of numbers. Now, those of you that are native AI practitioners, you can clearly see there will be NLP or NLU models or approaches that can help make sense of that quantity of data. Largely, though, other than a few webinars run by AWS and Azure and others, the opportunity to, at scale, begin to make sense of those publications and reports was underutilized, in spite of education receiving healthcare receiving an enormous influx of dollars and resources during COVID. So the challenge that arises, I think, is that we have a lack of effective conceptualization of how we think with machines, how we think with technology. And so we framed this just internally within C3L as really a problem of human and artificial cognition. And the challenge being, and we use cognition instead of AI specifically because we're looking at which discrete cognitive processes should be managed artificially by some kind of intelligence algorithm model, and which elements should be handled by human knowledge processes and social systems. So, for example, we've often felt creativity is a domain of human flourishing that AI, at least that's a public narrative, that AI won't necessarily encroach on. But if you've spent any time playing with GPT-3 or with DALL-E 2, or it could be Midjourney, or it could be any of the recent types of technologies, you'll realize that the pure act of creativity as an output, it can be in some cases indistinguishable when it's done by a machine or a human. Just recently made a fair bit of press is an art exhibit done by an AI system outperformed a human art exhibit or was ranked highest at a state level. Now, that may not be the most discerning art connoisseurs of the world, but the point is human beings in a certain setting were able to determine or feel that this output, which was really AI generated, was an enormous, certainly out better than what humans were able to produce. And so we keep bumping up against this. It's almost like we have this line of human cognition being an elite level of performance that other systems won't engage in. If it looks like it's coming close, like it did with chess, then we say, oh, well, actually, that's just a logic game. AI will always beat us at that. Then you look at complex strategy games like Go, and once AI blasts past it, we revert to, wow, human creativity and human connection is its own thing. And then we start to see GPT-3 writing provocative stories, and we start to see these video or these image outputs, and we're starting to bump up against the reality that we can no longer treat AI in education systems, in knowledge processes. And by knowledge processes, I mean things like learning, sense making, wayfinding, but the way that we orient ourselves to the world, to human cognitive processes. We come up against this point and say, okay, we've crossed some kind of a river or some kind of a bridge. We can no longer treat these outputs of AI as a resource or a technology that fits in traditional tool use standards that humans have adopted historically, which is this arrogance that we build something and then we use it as we want. Now, when we get into these processes, we start to ask questions. What does this AI system do to change a human cognitive process? If you've played with DALL-E 2 as a simple example, the output of creating art is now not the creative activity, it's the writing of the prompt that's the creative activity. So that the actual generation of what we used to think was art that's the thing that technology can do rapidly, efficiently, effectively, and AI can outperform us incredibly quickly in that space. So now we have to say, wait, creativity isn't what we used to think it was. And this is what I mean, where we're now in a kind of an entanglement where the artificial cognitive systems are encountering the human cognitive systems and not just being used by the human systems, they are changing the human systems. They are changing the value points in that. And to my thinking, that has stunningly enormous consequential impacts on the education systems. If I have a child in kindergarten now, or in level 8, or even early stages of university, the reality is that how she's going to make sense of the world will no longer be primarily by participation in a human knowledge system. It will increasingly, and at an accelerating pace, involve the integration of an artificial cognitive system. And then we raise critical questions. Well, if that's the way it's going to be, what should we be teaching? What do digital skills look like in that landscape? And perhaps most consequentially, how do we begin to teach people to engage with artificial systems in a way that says, we take the output of an artificial cognitive system, we bring it into our human cognitive systems, could be team-based or otherwise, we generate and create something, and then we hand it back to that system. You can see this in the myriad of fields. A confined space, like finding, let's say protein folding or those kinds of spaces, there's very known entity and it's a structured space. Problems like, how do we deal with climate change? How do we deal with social problems? How do we diagnose and treat cancer concerns? Those are all qualitatively different types of activities, but at the core, we're still dealing with some output of a system. Could be analysis of cancer images. It could be climate and environmental data, but the outputs that are being assessed by these artificial systems are being introduced into the human system and then being put back into those systems for further processing. Interestingly, in the education space, at least, we don't even have established theories that allow us to wrap our thinking around what these kinds of landscapes look like and what the ongoing subsequent implications are to the education system. So to my thinking, this is a fundamental digital literacy problem, but it's also a conceptual problem, because if you look at the Electronic Freedom Foundation's index of AI progress, where it comes into human cognitive process and where it outperforms us, we're teaching children, adults even, things that absolutely are a waste of their time as we see the acceleration of AI and artificial agents in those areas. So I'm perplexed by why we aren't having an actual broad scale conversation around the integration of these two dynamics and the theoretical lens that we need to bring to bear on the education process in order to meet that challenge and opportunity.
Okay, thank you so much, George. I think that's a very, very important, consideration with that intersection of those two systems. Maybe it's even a clash of those two systems, of what it means for an individual, what it means for systems, what it means for society. And I particularly liked your example with respect to the reskilling. Sometimes we use the word accidental data scientists. So a lot of the people in the fields don't necessarily have, formal training. Maybe that's a good thing. Maybe it's not a good thing. We just don't know. But as Nick pointed out, there is a lot more to building AI systems than just data scientists. So it's a much bigger journey we have to cross with respect to the skills. So I'd just like to thank all our speakers again, and we have got almost 15 minutes for Q&A. The floor is open to all our participants to put in your questions in the Q&A function using Zoom. We don't have a very big participant base over here, so I hope that we can go through all questions. So speakers, let's just give it a minute to see if anything comes up. Otherwise, I'm going to have a very good time asking lots of questions. Okay, so it's maybe going to warm up in a minute or so, but I think everybody spoke about skills to some extent. So I'd really like to come back to that point. You know, and it's fresh in my mind also because recently, as I mentioned, the Australian Academy of you know, Technology and Engineering has been running a pretty intense initiative around education and training and skills and digital skills, alongside a few others was part of it. And it's a very noisy space because it's not the first time people are talking about skills shortage. And so we try to come up with a bit of a framework to understand, you know, what are the different levels of skills, right? There's skills that billions of people need, right? Whatever, send a text message to, you know, and there's skills that millions of people need. Maybe it's more in the business space where we, you know, like my gardener sends me an online invoice. I just have to click 2 buttons and it's done, right? Or the QR codes in the restaurant. So, and then you just keep shifting it up. And we talked about the asymmetry. Nick, you mentioned that as well, you know, in the sort of enterprise space. And so maybe there are these millions of people, or I should say hundreds of thousands of people who have got the coding skills, who are in a sense implementing these systems. But I do see that there is a pointy edge, which is really really small. Maybe I read a report, I think it was from Tencent, that maybe there's about 30,000 people, and it's a few years old, that report, in the entire world that have got that skill set, which is, you know, the ones who are behind systems like TensorFlow and you know, PyTorch and others. And most of that talent is sitting with what you call digital natives, or you know, those consumer internet companies. So how do we navigate this skills shortage? And you know, I'm just going to refer to you, Sveta, you know, from a higher education sector's point of view. I know every university's got a master's program or undergraduate programs. What do you see as the big challenges in meeting these skills shortages?
It's a huge problem. We're just not training people fast enough, right? And as you say, I mean, every country needs these people at that pointy end as well, because even if it is to buy an AI system from somewhere else, you need to have these level of skills to understand the system well. So we need to train them in Australia so that we can't just rely on people to buy technology. And I think we're just not able to train people fast enough. How you do that faster and more efficiently, I don't know. Because the complexity that's required for even doing the most basic thing is increasing, right? Like even if you got some data and you wanted to find some patterns, there's always something you can do, but is it correct? Is it generalizable? There's so many questions that are much deeper that unless you have some training and some background, you won't ask. So there's a danger of these kind of technologies being just applied by people who are not well trained in some sense, and they achieve something, but the question is it what do you want to achieve? So I don't have any really good questions. I'm grappling with that myself as to how we can do it.
Yeah, but we are aware of that. Nick and George, would you like to add anything to this discussion?
I mean, I'd love to, Shazia, and I agree with Sveta that you know, these are quite intractable problems, and there's no silver bullet, because you've got to, not only do you have to train people, but there's a certain amount of having to, you know, having to have seen it, having to have experienced working in teams that have built these systems or build these systems regularly, that maintain these systems. And that's one of the big problems that we have, you know, that Google and Facebook and the others, you know, were doing this 10 years ago. And there's a whole lot of alumni that have come out of those organizations and then seeded the industry elsewhere, you know, outside of those that we don't have here. So that's point one. It's not just about how many people we can pull through the universities, and it is about how much experience they've got. So maybe it's thinking about how many we can bring home. I mean, I know lots of Aussies in the Valley and in Austin working in amazing companies doing interesting things that perhaps we could try and convince to come home to teach some of the people here that are coming through the universities and really need that leadership. But to your point, Shazia, about the millions and the billions, I think that there is a general, and Sveta's point is actually bang on the top of the nail, which is it still takes an understanding of these systems to buy them. It takes a deeper understanding to implement them. It takes an even deeper understanding to successfully design programs around them without writing a line of code or building a single system. And I just think of an anecdote that we were going through the Women in AI Awards and thinking about who of our amazing women in MK we were going to put up for it this year. And one of the comments was, I wish it was women around AI, because lots of the women in our team aren't the engineers. Some of them are the engineers on the actual machine learning systems, but some of them lead our front end and mobile engineering teams. Some of them work in our back end and API teams. Some of them work in our project management teams. Some of them work in our business analysis teams. Some of them work in our change management functions. Like there is, our regulatory team. There is, all of these roles that intersect with this technology because it really is, so cross-discipline. I mean, it's rare that we see technologies that really deeply interface with the business and the people, but are very, very technical and require a broad swathe of technical resources to bring to life. And that complexity is something to solve. And my view is that we should be giving, we teach stats to everyone that goes through university, right? Rightfully so. Everyone should understand it. We should do the same for deeper technology, not how to use Microsoft Word, but how to write a bit of Python, what the cloud is, how basic machine learning works, these core principles that really you need to operate in a world that is defined by digital. There is no role anymore that digital doesn't intersect with your job. I mean, as George rightly pointed out, even art is now, as much about how you write the prompt for GPT-3 or DALL-E than it is, how you put paint to brush. These fields are merging together, and everyone needs some appreciation for the core principles that underpin them. Because if you are trying to operate in a world of black boxes, things are going to get really hard. And so, can we rethink about what some of those core skills are that we need people to come through university with? 20 years ago, it was word processing. I don't think we need to do that anymore. But I think today we've got to ask some questions about some of the core principles that people do need. And I think AI skills are one of those.
Yeah, agree. Really good points. We have got one question come up, but George, would you like to add to this conversation first?
Yeah, just a few quick points. So first of all, I think there's one of the problems that we have with our education system, and I think it's fundamentally a systemic problem in that the nature of how we teach each generation assumes a stability of knowledge or a fairly slow growth or linear growth of knowledge in a field. What we have today, though, is new fields arriving almost overnight and then requiring a massive human skill set. And if you look at where are big companies that are huge hires of these tech resources or these tech skills going to develop? Look at Coursera. Google has their own certificate on Coursera. 30 years ago, 40 years ago, Microsoft would partner with a university and say, let's run a master's and we'll use some of our core technologies or our .NET infrastructure or whatever else, and away you go. So today that's changed. So I think there's a real, there'll be a complex thing, and I haven't quite seen what I think will come out of this yet, but it's either universities are going to wake up and accelerate the pace at which they interact with growing trends that have a knowledge component, and then perhaps continue in their sort of fairly supreme role in knowledge dynamics in society, or which currently this is how it's trending, you'll start to see the emergence of secondary ecosystems that do the rapid skilling and knowledge reskilling of those populations, bringing people back into the workforce, into ongoing learning and development, and so on. So that's, I think, part of the issue. So, and Sveta's point about the need to do that type of training and development at scale, I think is one that initially was the interest and the intent with open online courses or similar kinds of activities, which would allow us to rapidly take 250,000 individuals and give them the basics of data science or give them the basics of learning analytics. But even then, there's the human dynamic, which we found quite quickly, is that there is something that happens when we work on a team and when we interact with other people and when we share ideas and when we take turns developing ideas. We co-develop and co-evolve with our teams. And now we're co-developing, co-evolving with our teams of human teammates, but also potentially AI teammates. So to the bigger question is, so that's the one thing, is we have a systemic inefficiency that is not meeting the needs of knowledge dynamics in modern society. Secondly, we have processes that need to be centered on teams and teams primarily as a means for us to build and develop knowledge going forward. Thirdly, we have a pretty substantive challenge, which I'll say, if everything is digital, which it is, then the next thing to think about of everything is teams, which it is, meaning that connected specialization is the pathway out of these dynamics. We need to have everyone become literate in the dynamics of, I'm working with somebody who's an expert in NLP, and I'm working with somebody who's an anthropologist. Can we together, as this cluster of people with dramatically different skills, we've always had this view, you need to have knowledge adjacent skill sets in order to participate in that conversation. It's just impossible anymore. The knowledge fields have splintered so fine, such a fine-tuned way. I think a critical skill set needed across all sectors of society is the capacity to engage in knowledge processes about spaces in which you have absolutely zero knowledge, but you know when you need it, you know when you need to connect it and activate it within your own network. So the idea of connected specialization, or the fact that after everything is digital, everything is teams. That's the only way you start to address these complex kinds of scenarios.
Really good points, and I think I'll go to the questions in our last few minutes. But exactly what Nick mentioned, you know, it's not just in AI, but around AI as well. So all those additional skills and functions. So
yeah, I'm gonna steal that saying, George. I love it.
Excellent. So we have a question from Isaac here. In just with regards to when we're discussing AI, we compare Australia to other jurisdictions like Silicon Valley. Does anybody know about the policies or activities they have fostered and prioritized that underpin their success?
I mean, I'm happy to give 5 seconds to this, Shazia. I think it's really difficult to point at any single policy that particularly the Valley has instituted that guarantees its success. In fact, the current political environment is almost hostile to people that live in the Valley and you know, in California, and that's causing a large egress to Texas of all places. But that's a very different story. But really, what creates the Valley? It's the circular nature of innovation through to success, through to capital, and back into innovation. And that's the real hallmark of that economy and other great, you know, areas in the world. I mentioned Tel Aviv before, is that you see an early, you know, investment in innovative technology, and you see that translate into wealth through success. We go back to Intel and Apple and, you know, the early Silicon Valley residents, Hewlett Packard, et cetera. And then what you see is that wealth not be, you know, spent on private planes and islands, but rather put back into the ecosystem by founders investing in new founders, in new ways of technology. And this cycle just repeats and repeats and repeats. You know, Peter Thiel, founder of PayPal, now, you know, founder of a Founders Fund. You know, David Sachs, also in PayPal team, now founder of Launch Ventures. You know, and and then you obviously have the people that were in those companies have seen those things that can then join new companies and give them advice. And so at some point, you just got to do it because there's no way to shortcut it. And I think Australia, I mean, I've been in the sector now for a long time. We have come so far, and we are starting to see those circular economies. We're seeing founders reinvest. We're seeing, you know, big exits. Atlassian, obviously, Canva, you know, Airwallex, amazing successful companies, and that's starting to feed back into the sector. So I'd say I don't think it needs policy more than it needs time, and it needs fuel, and people and skills and capital are fuel.
Yep. That's very heartening to hear from you. So George, perhaps a 30-second response to this question, and then we've got another question for everyone.
I'll keep it shorter than 30 seconds. If you're looking for an interesting analysis of why Silicon Valley became Silicon Valley, there was an interesting, if you just Google secret history of Silicon Valley, there's an individual, I believe it was Steve Blank, that did a nice lecture, I think at Berkeley a number of years ago, that just sort of summarized a lot of what Nick was talking about. But there's an interesting entanglement between public money and community responsibility and people just driven by innovation and the desire for new ideas.
Yep. Thanks for that. So another question by Alim, and thanks for the great talks on translational AI. I would like to ask if there are any existing theoretical frameworks which relates to AI technology, which relates AI technology with business value, and can they be leveraged in industry? Has any such research been done? Because I think Alim's question.
I don't understand the question. Business value, does it say?
To relate, I guess it's the monetization. So yeah. So AI technology with business value. So what return on investment? Are there any
well, if you think of it on a shorter time frame, like maybe in an experimental design framework, like how do I produce this product as lowest cost? AI can and has done that. But if it's a much more long-term thing, then that's I'm not aware of any direct research.
Yeah, it is indeed a very hard question. So we are just a minute over time. I would perhaps just invite any of our speakers, if you will have any concluding remarks, what needs to change, what you would like to see in terms of research industry partnerships and their growth in Australia?
Well, I guess more partnerships. That's always a good thing.
Yes, second that. Nick?
Yeah, look, I'll second that. I think more partnerships, but I think thinking about where those partnerships create the most bang for buck. I think both the higher education sector and the industry sector are resource constrained, and so we've got to be really smart about where we put our focus to create the biggest impact. And that can be skills, it can be fundamental research, it can be frameworks, as the questioner mentioned before, but just thinking really clearly about what we want to do, why we want to do it, and what value it's going to create for the long term.
100%, yes. George, any final comment from you?
I just want to emphasize again that a lot of the questions we're dealing with are systemic in nature, and that requires vision and some visionary guidance and redirection. I think, especially in the Australian AI, in my case, more related to the technology and ed tech sector, the status quo isn't the pathway out. More of what we have, more investments in what we have isn't the path forward. It's thinking completely differently about the systems of learning and the systems of knowledge production and the ways that they're supported, both in terms of research and industry outputs, I think is what's critically needed.
Thank you so much. So I'd also like to thank all of our participants over here. So just a quick note that the recording will be sent to all registered participants. Also an open invitation to everyone here to reach out to us for future topics, for research industry collaborations in any of the emerging digital technologies. There's no shortage of them. And once again, thank you so much to the academies for setting this up. Thank you so much, Sveta, Nick, and George, for your time.
Thank you, Shazia.
Thanks, Shazia. Thanks for hosting.
All right. Thanks all. You bet.